Hi, my name is Mohammed Uwais and I'm the creator of gUrrT, an intelligent video understanding system. Right now, the video understanding landscape is dominated by large video language models as well as mainstream tools like the YouTube's Ask feature. While these are undeniably powerful solutions, they come with critical limitations. Tools like YouTube's Ask operate within closed ecosystems, relying heavily on basic transcript and proprietary cloud models. On the other hand, state of the art LVLMs perform multimodal reasoning by processing continuous streams of visual tokens alongside LLMs. This makes them incredibly GPU intensive, making local deployment on standard consumer hardware completely impractical. To get around this hardware bottleneck, developers are forced to rely on cloud inference, but that introduces high infrastructure costs, scaling issues, and severe data privacy risks since you have to upload your video on an external server. Is exactly why I built Code. My solution bypasses this traditional heavy video language LVLM route and converts the video not as a continuous stream but as a searchable collection of meaningful moments. It is engineered to deliver high accuracy video understanding locally on consumer grade hardware with just 4 to 8 gigs of RAM. In order to achieve this, I engineered a pipeline utilizing advanced frame sampling techniques, audio transcription, as well as a RAG architecture. Instead of analyzing every frame, I use Python Detect to split the video into scenes and pick three anchor frames in order to represent the visual summary. I initially tried the SSIF of frame sampling, but it was too time consuming and had to be discarded. If no scenes are detected, uniform frame sampling acts as a fallback. These anchor frames are then converted into high-dimensional vectors using clip embeddings for semantic indexing. Crucially, gUrrT performs image captioning to generate text descriptions for each frame per scene. I extensively tested BLIP, a very primitive vision language models that generated pretty crappy captions but acquiring very little VRAM. In order to improve my caption quality, I swapped it with a more VRAM heavy model, namely Gemma 3, which vastly improved the context quality. When simultaneously, Faster Whisper extracts and sequence the audio into timestamped text chunks, and all this multimodal data is then stored locally in a ChromaDB vector database. Now, this is all about indexing. At Inference, I introduced a cross encoder that refines the retrieval results by jointly evaluating query document relevance for precise ranking. I also integrated supermemory, which isolates and refreshes contextual memory per video to preserve response accuracy and prevent contamination. Finally, I routed the inference to Llama 70 billion model via Grok with flexible support for local executions using models like Gemma 3 via Olama. The improvement in response quality was phenomenal. Today, gUrrT is developed as a PyPy package and is available as a powerful CLI-based tool with more than 1,000 downloads. While the current architecture excels at answering specific queries and handles 10 to 15-minute videos beautifully, it currently relies on vanilla RAM. Because of this, it struggles with global tasks such as summarizing an entire video. Moving forward, I'll focus on two major areas. First, I'm working on implementing a more advanced RAG architecture to enable better retrieval and global video understanding. Second, I plan to tackle the temporal dimension, which is an area where LVLMs currently take the lead. Finally, I'll be rigorously benchmarking these new implementations against existing models. So, this was all about gUrrT. Thank you so much for your time.